This is page 178, section 3.4, number 7, 9, 12, and 13. And so the formula for permutation, with permutation, order matters. So you're talking about vice president, president, secretary. So order matters with permutation. So the formula for permutation is going to be n factorial over n minus r factorial. So in this case, we've got 7 factorial over 7 minus 3 factorial, which means 7 factorial over 4 factorial. And factorial means you multiply every number times the number less than it, all the way down to 1. So 7 times 6 times 5 times 4 times 3 times 2 times 1 over 4 times 3 times 2 times 1. These last few numbers are always going to cancel out, which is really nice. So it's just going to be 7 times 6 times 5. And so we can use our calculator and get that, and that would give us 210. And there's another way to do this also. So let's write that down. That's going to be 210. Let me show you a couple other ways to get that solution using our calculator. So let's clear this out here. And to get this in our calculator, we're going to start with the first number, the 7. And then we're going to click the math button, and then we're going to go all the way over to probability. And when you go over there, you see that number 2 is NPR, which is what we're using. So we're going to press number 2, or go down to 2, press enter, and then we're going to type in a 3. And that's going to also give us the 210 that we had there. So to do C, combination 7, choose 4. So we're going to type in our 7, go to math, over to probability, and choose number 3. And then we're going to type in our 4. And so combination 7, choose 4 is going to give us 35, which is a whole lot less because order does not matter. And so let's say we want to do something like this. We put that all in our calculator at one time. And so we're going to clear this out here. So we've got combination 8, choose 4 divided by combination 12, choose 6. We're going to just do 8 math. I'm going to go to probability. I just went back one to go the other way. And that's number 3. And that's going to be choose 4. And then just divided by 12 math, PRB, number 3 there, or just go down to 3 and press enter, choose 6. And so that'll give us, C is going to be 0.076 rounded off 3 decimal places. Now let's take a look at number 13. We get our permutation here, 6, choose 2 divided by permutation 10, choose 4. So we're going to start with our 6, go to math, and then to probability. Number 2, I'm going to choose 2 of those, divided by 10, math, the probability, number 2, choose 4. So that'll give us 0.005. Rounded 3 decimals correctly would be 0.006 thousandths. The permutation and combination are quite different in answer, and the formulas look the same, and you can try those formulas out too. This is section 3.4, page 179, number 25. A landscaper wants to plant 4 oak trees, 8 maple trees, and 6 poplar trees along the border of a lawn. The trees to be spaced evenly apart, and how many distinguishable ways can they be planted? So our distinguishable permutations formula is n factorial over n1 factorial plus times n2 factorial times all the way to nk, where the sum of these is equal to the numerator. So in this case, we've got 4 oak trees, 8 maple trees, and 6 poplar trees. So our numerator is going to be the sum of those. We're going to do our 4 plus our 8 plus our 6, and that'll give us 18 trees altogether. And so that's going to be the numerator, 18 factorial, over the product of our 4 factorial times 8 factorial times 6 factorial. And so let's do that using our calculator. And so we're going to start out with our 18 factorial. To get to the factorial, we can just press our math. We're going to go over to the probability, PRB. You can go to the right arrow 3 times or just go back arrow 1. So that's number 4. So we can just press 4, and that'll give us our 18 factorial divided by, I'm going to use parentheses for the denominator here. So we're going to do 4 factorial by just going to the math again, over choosing number 4. You can also go down and press enter. It'll do the same thing. Times, and then we've got our 8 factorial, 8 math, arrow over number 4, times 6 math probability number 4. And I'm going to close that parentheses and press enter. And it's a really large amount. You wouldn't think it's this much. And that's going to be 9,189,180 different permutations of ways to put those trees. Section 3.4, number 53, a warehouse employs 24 workers on the first shift and 17 workers on the second shift. 8 workers are chosen at a random to be interviewed about the work environment. Find the probability of choosing, first of all, for part A, all first shift workers. And so we've got 24 workers on the first shift, 17 workers on the second shift, and we're choosing 8 altogether. That's how many we're choosing. So our formula is going to be our first shift, how many are we going to choose, and choose R, times second shift, we're choosing how many out of, the R is how many we're going to choose out of how many we have, and this is going to be our total down here, T for total, and choose R. And so for this problem, our first shift is always going to have 24. And so this N here is going to be 24. And our second shift, the total, is always going to be 17. Well, this number here, the N here, has to always be the total of those two. So we're just going to add the 24 and the 17 together. And that's going to give us 41. So it's going to be 41 for the total down here. And we're always going to choose 8. So that's going to be 41, choose 8 here in the denominator. Okay? And so the only thing that's going to change is this R here and this R here. And so for part A, all first shift workers means that this R is going to be 8 because we're choosing 8. And so that means how many are left to choose. If you choose all from the first shift, you choose none from the second shift. So let's do that in our calculator. So let's get our calculator out here. So we're going to go to our calculator here, and we're going to start with this number right here, the 24. And these are combinations, so to get our combination, we're going to go math, and then over to probability number 3. We're going to choose 8 of those, times, and you don't have to do this part because 17 choosing 0 is just going to be 1, but we can go ahead and put that in because it's going to help us to use our calculator a minute here. Let me show you what I mean. Number 3, choosing 0 of those, and then we're going to divide that by 41, and then combination, math, 3, and we're going to choose 8 of those. And so that's going to give us 0.00769. Let's go 4 decimal places rounded correctly, and so that's going to give us 0.0077 for part A. And so let's take a look at part B. Now we've got all second shift workers. So in the case of all second shift workers, then it's going to be still combination 24, and if we're choosing all second shift, we're going to have no first shift workers, and we're choosing 8, so we're going to have 17 choose 8, and then the denominator is going to be again the 41 choosing the 8. Let's get our calculator here, and we can just hit second enter, and it'll bring up what we had from the last time. We can just back arrow and change those things. So this 41 choose 8 is going to stay exactly the same. We're just going to go back over here to this 24. Instead of choosing 8, we're actually going to choose 0 of those. So we can just change this 8 to 0. This just saves you a lot of typing. And then we're going to change the 17 choose 0 to 17 choose 8. So let's go over there and change that 0 to an 8. And that'll give us, now here it says 2.54426 something 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 to the negative 4. Well, when you've got the e to the negative 4, that means times 10 to the negative 4. Move your decimal 4 places to the left. So that's going to move our decimal 1, 2, 3, 4 places to the left here, and that'll give us 0.000, and it's going to give us a 2, 5, and that 5 will round the 2 up to a 3. So that'll give us 0.0003. Let's take a look at part C. For 6 first shift workers, that means this 0 is going to become a 6. So we're going to have 6 first shift workers. So I'm just going to change that 0 to a 6. And if we've got 6 first shift workers, 8 altogether, these have to add up to the 8. So we're going to need 2 here. So if we go back to our calculator, and we're going to just hit the second enter again, so I'm going to type everything all over again, that 41 choose 8 is going to stay exactly the same. let's go back to the beginning here. So that 24 choose 0 is going to become 24 choose 6, and then we're going to choose 2 from the 17 here, and that's going to give us 0.19157. So we're going to round that off to, so we got 0.19157. So we look to the 7 here, makes that 5 go up to a 6. So it's going to be 0.1916, rounded correctly. For part D, so for part D we want 4 second shift workers, and so I've just got the same formula. I'm missing these 2 numbers here, and so this is going to become 4 second shift workers and 4 first shift workers, because there's 8 altogether. And then we'll go back to our calculator, we'll type second enter again, and then we'll just change that. 41 choose 8 is going to stay exactly the same. We've got 41 total choosing 8. So we're going to choose 4 from the first shift, the first 24, and then 4 from the 17, and that'll give us 0.26468. So to round that correctly, 0.2646, and after that is going to be an 8. So that's going to give us 0.2647, rounded correctly.